Okay, so let's pick up. I know that we did some of these yesterday, like I just said. I want to let me see if I did those. Yeah, let's do some additional problems and then we'll look at the homework. So these are not in your book. Here's my pen. We're going to finish up on section 4.5 before we move into 4.6. All right, so what I want y'all to look at here is no, I can't talk and write at the same time. Are the following sequences arithmetic?
Arithmetic? Yeah, of course it's not even arithmetic. It's all arithmetic.
No, it's not all an arithmetic sequence. We have geometric sequences that we'll learn about. We have all different kinds. So if I give you 4, -8, 16, -32 to infinity, is this an arithmetic sequence?
No.
So what's the definition of arithmetic sequence? It has to have a common difference between each, what's the word?
Term?
Well, each following term. I keep wanting to say coinciding, but you have to have the same difference between each term as you move through the sequence. So what's the difference between 4 and -8? -12, right? You went from a 4, you went down, so it's negative, and you went down 4 until you got to 0, and then you went down another 8. So it's 8 + 4, which is negative. So -12. But then what's the difference between -8 and 16? 16 + 8, yeah, so +24 because we moved in the positive direction. And then the difference between 16 and -32? Something big, right? So it's 32 + 16, but it's negative because you got smaller. So it's 48. So you can see how these, there is a pattern here, but it is not an arithmetic pattern because arithmetic pattern must have, or sequence, excuse me, must have a common difference, right? You must have that D. So this is, no, this is not an arithmetic sequence. All right, let me give you another one. Let's see here. Number 2, lost my place. 5, 15, 45, 135 to infinity. Is this arithmetic? I heard a question on the end of that no. No? Or no? Yeah, no, you're right. You're right. It's not. And you can see very quickly because the difference between 5 and 15 is 10. But then you jump to a 30 difference. And then you jump to a 90 difference. So again, we may have a pattern here, but it is not an arithmetic sequence. So again, that one's a no. All right. So what about -4, -2, 0, 2? Yes. Yes. An emphatic yes. Yes, it's good. It is an arithmetic sequence. We have seen this before. We can work with this, right? Every one of them increases by a +2. It's going up by a difference of 2 every single time. All right. This makes sense, right? Y'all see where I'm going here. Sort of 20, 12, 4, -4.
Yes.
Because what's our difference? 8? Definitely 8? Is that your final answer? Are the numbers getting bigger or smaller?
Negative.
It's so early for this.
Yes.
But the numbers are getting smaller, right? So this is a -8, but then it continues with -8. And then the difference between 4 and -4 is -8. So yes. So yay, we have another one that is an arithmetic sequence. Okay. All right, so let's do some practice making, writing the explicit formula, and then we'll have a little bit of practice writing recursive formulas. I didn't wave back. Okay, so give me an explicit formula. For, what do I have here? 2014, 8, 2. Are you singing? I couldn't figure out where that noise was coming from. All right, so first off, what's our base formula for an explicit formula? A n equals, do we remember this? A1 plus, there we go. Yes, this formula you better have in your notes because you're going to want to have it available when you work on your quizzes and your tests. Okay, so this is what we call an explicit formula. So let's, we don't know what n is. They're not asking us to find the term for position n. So those will stay the same. However, do we have an A1? Do we have a term in position 1? It's 20, the first one in our sequence. Do we have a value for D? What is it? -6, right? The numbers are getting smaller. They're getting smaller by exactly 6. So we have D equals -6. So you just take this formula here and you plug that in. So our n stays the same because we don't know what it is. Well, what is A1? 20 plus n minus 1. And then what is D? -6. All right, so this is where we still need to simplify. This is not as simple as we can make it. We can do more. So, right, we need to distribute our -6 into our parentheses to get rid of our parentheses. So when we do that, we find that AN equals 20 plus what? -6n plus 6, because a -1 times a -6 is a positive. Yes. Don't forget, you must always, those subtractions, you need to know how to manipulate and turn a subtraction into a negative number or a negative term. Take that negative with the term that follows it. In this case, it's 1. Okay, so let's continue to simplify. And we end up with AN equals, we got this guy and we got this guy. 20 plus 6 is 26. And then we would rewrite plus -6n as minus 6n. Because adding a negative number is the definition of subtraction. Yes. And this is as simple as it gets. But this way, and I know we did it 2 different ways, and this way got a little bit confusing yesterday. But once you have this formula, if I tell you I need position 56, I need position 103, and I need position 265, you can just plug that in for n, and it will, you've already got it right. You just plug that value in and then do the subtraction, and then you're done. Multiplication and subtraction. Right, okay. That's why we simplify it. All right, so let's look at this again. Anybody want to try to do this one? Noah? Okay. Yeah, I'm writing it on the board. This is not, so these are not in your book. That's why y'all got to kind of write as we go. So if I gave you the sequence, -10, -7, -4, and -1, write me an explicit formula with this for the sequence. Okay. Yes, because even though all our numbers in our sequence are negative, they're still getting bigger in value, not necessarily a number, right? So eventually we'll get positive and then we'll start getting bigger numbers. All right. So distribute. Plus a -3. All right. Okay. Okay. And then do we want to rewrite this so it's a little neater? We could, because we've got the commutative property of addition. Means that any number plus a plus b is equal to b plus a. So you can just flip this around. So it's 3n minus 13. Right? That's the same thing. We all see that? Okay. And yes, we are done. Just before I check my answers. Yeah. Okay. Cool. All right. So let's write the recursive definition for the following sequences. Now, with recursive, why do we call it a recursive definition instead of a recursive formula? You may know. So I need recursive. Well, a recursive definition includes a formula, but it must also have what? We have to define the first number in our sequence when we write a recursive formula. Because with an explicit formula, all you need to know is the position that you're trying to calculate the term for. With a recursive formula, you also have to know the start of the sequence. You have to know that first number, because recursive, we go from position 1, we use position 1 to calculate position 2, and then we go through all the positions. So when you write a recursive definition, it needs to include A1, which equals some number. And then it must also include the formula, which is AN equals AN minus 1. So the term of the position we're looking for, position N, equals the preceding term, N minus 1, plus what? Our difference, because we're just going from position to position. We're just going through. This was the first part we learned. So I should probably make this X, because it's different than the position number. All right, that's why we call it a definition, because first you have to define the first number in your sequence, and then you write your recursive formula. Okay, so in this case, they're giving us the sequence. So for number 7, I give you the sequence -4, -2, 0, 2. Then you can pretty easily write your recursive definition here. So A1 equals what? -4. So we're giving our starting point. And then AN, so the term in position N, we don't know which position, we're just writing the formula, equals what? Well, in this, let's see. Yeah. How do they put it? Yep. AN minus 1 plus what? 2. And that's it.
That's a lot of writing.
A little bit. But we remember what all this means, right? No? So AN is AN minus 1 plus D. This is our recursive formula. So AN, oops, is the position trying to think how to word this. So this is the position where we're finding the term. That's our unknown. We're trying to find the term that exists in position N. This one is the term in the preceding position. And then we know what D is. That's our common difference. Right? So when we use a recursive formula, you remember instead of an explicit formula, recursive formula, you have to know the term in the position before, the previous position, before you can calculate this, the term in this position. So that's why it's a little bit different. So we're calculating the term that exists in position N. This is your position number. Whoops, made a mess. That's why, yes, and that's why with a recursive formula, you have to make it a recursive definition by defining your first term. Because once you know, did we actually do any of these? No, let me show you. So like if I know that A1 is 20, and I know that D is 5, and I ask you to tell me what is the term in position A3, that's our unknown. Well, I have A1, so I have to calculate A2 before I can calculate A3. So I would set this up where I know A1, so AN equals AN minus 1 plus D. Sorry, these are kind of all over the place. So AN is A2. That's my next one because I know if I plug 2 in there, 2 minus 1, and then simplify that. So A2 equals what's 2 minus 1? A1. And I know that. I was given that here. And that's why that position 1 has to be included with a recursive formula because you have to know where to start. So then I can plug in A1 and D and calculate A2. So then A2 becomes 20 plus 5, which means A2 is 25. And so now that I know the term in position 2, I can now calculate using a recursive formula the term in position 3. See, the explicit formula kind of makes the recursive formula obsolete because it eliminates this step by step by step. So if I want to find A3, now that I know A2, I can do that. A3 equals A2 plus D. So A3 equals 25 plus 5, so it's 30. So now I have the sequence 20, 25, 30. Okay, we have a little bit there. We'll do this when we do the homework too. Okay. All right, so let's go ahead and get to the homework. I know we did some of this, so let's do it. Let's do it again for those that are not here. So I've got it in my video. I did continue recording, didn't I? Yes, I did. Okay, so for number 14, I'm on page 157. Y'all probably have this in your notes. Did I give y'all odd or even? I did give y'all even. Okay, good. All right, so for number 14, 14, 16, and 18, they're asking us to write the first 5 terms of the recursively defined sequences. So this, again, this is our recursive definitions. And the reason they're definitions is because they had to give us A1. So for number 14, we have that the term in position 1 is -1. And our formula is no, not little n equals minus 1 plus 8. So that means our common difference is what, Matthew? Yes, 8 is our difference, and it's positive, so we're good. All right, so Rachel, I need to find the first 5 terms. So I need to know what A2 is, A3, A4, and A5. So how do I calculate A2? So A2 equals the value in A1, so -1 plus 8. Therefore, it is 7. Very possibly. You can just do it. I mean, there's even easier ways to do it too, but right now we're learning the process because we're probably going to use it in more complicated ways later. Yeah, you're fine. So A3. So really all you have to do to calculate A3 is you just take the 7 plus 8. So it's 15. A4 is 15 plus, do my 5s like that, 8, so 23. And then A5 is 23 plus 8. No, yes, yeah, 31. Okay. And so then you have your sequence, -1, 7, 15, 23, 31. And you're done. Okay. So let's move on to writing the recursive definition for the sequences. Did we do 20 yesterday? Does anybody have that in their notes from yesterday? I think we did. So what about 22 and 24? Well, but you did all your homework too. So I don't know if we did it in class or I think we did though. Let's go ahead and do it for the ones watching. So the recursive formula, we have that from before, is or the term in position n equals the preceding term plus the difference. And for number 20, what's our A1? Well, let's see here. Write the recursive definition for the following sequences. Yeah, so what's the value of A1? 3. And so then we have AN of any position equals AN minus 1. And what's our difference? +4. Right. And so then we're done. That's our recursively defined sequence. We've given our starting point, A1, and then we've given our formula that includes the difference. All right. And then the answer for number 22 is A1 equals -2. And the formula is AN equals AN minus 1. And 22 gets smaller because they're getting more negative. AN minus 1 minus 4. All right, and then 24 is A1 equals -2. And then AN equals, or the term at position N equals the previous term. And then is this one, looks like this one is +8. Yes, thank you. +8. So your difference is +8. So that's your recursively defined sequence. Okay, so what about 26? I think we did 26 and then that's the last one we did yesterday, right? Maybe. I don't remember. Sorry. That migraine totally reset my brain yesterday. Let's just go ahead and do it. So for number 26, they want a simplified form of the explicit formula, which means we need to do the use the distributive property to simplify it. So our explicit formula is AN equals A1 plus N minus 1 times the difference. So AN, what's the term in position 1 for number 26? Oh, 7. Okay. 7 plus N minus 1. And then what's our difference? 4, positive 4? Looks like 4, positive 4. Okay. Now we need to distribute that 4 into our N minus 1 to get rid of the parentheses. Excuse you. AN equals 7. And then 4 times a positive N is 4N. 4 times a negative 1 is minus 4. All right, and so then we just simplify our constant terms and we end up with the simplified formula AN equals 3 plus 4N. Or to use our math etiquette, it's AN equals 4N plus 3. What'd you say? You got it right. That's very exciting. Yay. All right, let's look at 28. I think now we've gotten to the point where we're doing ones that y'all did on your own for homework. All right, so number 28, we have the sequence 11, 8, 5, 2. Negative 1. You said you don't know if you got this one right? Okay. We're on 28. This one y'all did on your own for sure. Okay, so again, we're still doing explicit formula, so we don't need to define A1 besides we already have it. But AN equals, what's the term at position A1? 11 plus N minus 1 times what? Negative 3, because our numbers are getting smaller. All right, so AN, let's simplify 11 plus negative 3 times N, negative 3N. Why did I do that? Oh, because it's negative. Okay, and then negative 3 times negative 1, positive 3. All right, so now let's just combine our like terms. So 11 plus 3 is 14 minus 3N.
Plus 14.
Yes. Yes. So you could rewrite that. If you're really going to keep things consistent, you would write that as negative 3N plus 14. You put 8? You subtract, you forgot the negative 1 times negative 3. So you made it a negative 3. Okay. Yeah. Y'all are going to get tripped up by negatives forever if you don't remember to include them with the term that follows them. Know that a subtraction is just adding a negative number. So sometimes you just throw that negative sign with the number instead of leaving it hanging out there to mess you up. Okay, number 30. What time is it? Whew, okay. Number 30 gives us the sequence negative 8, negative 2. Somebody tell me, what are we doing here? Negative 8, negative 2, 4. And then 10. Oh, and they give me one more. Okay. Yeah, I need help this morning. Okay, so we're still working with explicit formulas. So AN equals A1. What's the value at A1? Negative 8 plus N minus 1. And then what's our difference? Positive 6. Yes, we're getting bigger. Okay, so distribute AN equals -8 plus 6N minus 6. What's -8 minus 6?
-14.
Good girl. -14. You are alive. All right. Yes. -8 minus 6 is the same thing as -8 plus -6. Like term or like signs. So we add them. Just don't forget to keep the sign. So of course I would turn this into 6N minus 14. All right. Anybody get that one?
I do.
Good
I
job.
don't know what the heck I was doing yesterday.
You had confused your formulas a little bit. Because I remember when I was looking at it, I was like, oh, wrong formula. You're plugging everything in the right place, but you're using the wrong formula. But then I never came back to you. So we ran out of time and I knew we'd work through them today. So sorry about that. Okay, so let's do some actual finding sequences and some different terms. Absolutely. Use your calculator. Right now, I want y'all to focus on these formulas and how to manipulate them to find what you want. Let your calculator do these crazy multiplications. Good job. I mean, hey, it's if you understand the process, you need to go back and practice your math. But if you need a calculator, that's okay. At this point, I need you to understand these formulas and how to use them to find information more than I need you to remember how to multiply large numbers. Because I know that takes time and y'all got a lot on your plate. So
I only use a calculator for the last 3.
when the numbers started getting really big, yeah. It's really, at this point, it's more of a time thing. Now, if you struggle remembering how to multiply numbers, you need to do it by hand because you need to practice. But if it's just a time thing, because it takes time when you're multiplying large numbers times large numbers, just use calculator. 10, 23. Okay. All right. So we are told to find A1 and D. So for this one, A1 is what? Yes. And D is what? Yeah, it is. Okay. Positive 13. These numbers are getting bigger. All right, great. Now, so that's the first part. So now we need to find the term at position 50. That's what A50 means. It means find the term at position 50, right? Say what? 89.
Yeah.
Oh yeah, we'll get to that in a second. One at a time. Easy. Same process. Okay, so what does this formula look like? Yes. Okay. Excellent. That is correct.
I didn't write down formulas. I just wrote up the answers.
Okay, well, write out the formulas because if you get a quiz in front of you and your mind goes, then you're going to need to have an example where you can see your steps. You have enough of those probably from us working them in class, but let's check your answer and see how you did. So this means -16 plus 49 times 13. All right. So, but you did it right though. Hey, that's what counts, right? 637. All right, and then what do we need to do? -16 plus 637 just means 637 minus 16. So did everybody get the answer 621? You did. Good job, Rachel and Noah and everyone else that got it. Okay, so A89. That's what you said, right? Position 89, that's what we need to calculate. All right, so the term at position 89 is what? Yes. Negative 16 plus 89 minus 1 times 13. So let's get rid of our parentheses. Let's do that math. So 89 minus 1 is just 88. 88 times 13 starts to get humongous, negative 16 plus 1,144. So you just need to be able to recognize that that's the same thing as 1,144 minus 16. So the position, the term at position 89 is what? What'd y'all get?
1,128.
Yes, 1,128.
I did that without. What? You guys are head?
Look at you, big brain.
I didn't do it while Brandon. I did it.
You just worked it out.
Oh, yeah, I worked it out. Oh, I did too.
We're so competitive. I love it. It scares me because I'm not, but I love it at the same time. All right, so number 34, 8, 3, negative 2, negative 7, negative 12. Are these numbers getting larger or smaller? So our difference must be what? Well, if they're getting, if the numbers are getting smaller, then your difference must be what? Negative. It has to be negative because they're so funny. All right, so I'm glad y'all are waking up anyway. All right, so our difference is negative what? Negative 5, yes. And then what's A1? That the term, or sorry, I call it A1, but I can also say, what is the term at position 1? That's what A1 means, right? So what's the term at position 1? It is 8. So now let's plug everything in. What do we need to calculate? That's right. The term at position 50 and the term at position 89. All right, so the term at position 50, what's that formula look like?
A plus 50 minus 1.
Yes, 8 plus 50 minus 1 times negative 5. Don't confuse that with minus 5. It's a negative 5. All right.
Like I know, like how other people know. Never mind. They get taught. I know what they have to know what they do. I use mine. I'm confused. No, you're just like, how do people?
I should do this.
They don't know.
That's what I should do. I should put a negative 5 in parentheses. Exactly, because parentheses, the asterisk, and the X all mean multiplication. So you're right. That was a really good question, because how would they know? It's because it really needs to have a parentheses around it. Okay, so that was a good note. I should do that. All right, so let's go ahead and simplify until we can solve. So 50 minus 1 is 49 times a negative 5. 49 times negative 5 is negative 245. So the term at position 50 is 8 minus 245. What? $37. Yes. Negative 237. All right, position 89 has the term 8 plus 89. Can we just go and write 88 here?
Yeah.
Can we just say 88 and we know where that came from?
Yeah.
Times negative 5, which is our difference. If not, go ahead and do it the other way. But we know it's just the preceding position. So it's just one number less, always. All right, so 88 times negative 5 is negative 440. So 8 minus 440 is what? It's just 40 minus 8. Right? Just remember to add the 4, add the negative. Yes. So negative 432. I feel like I should just check my answers in the book, make sure I'm doing this right. What was this, number 34? Yes, negative 432. We got this. All right, how do we feel about this? We feel like we understand this? We know what to do? As long as you have your formulas, you know which one to use where? Okay. Let's keep going. This is our last one, right? And then I want to work through 38, at least a couple of these C exercises. 38, 39, or 40. Okay, so number 36 is negative 25, negative 21. Then what? Somebody help me out here. Negative 17. And then, and that's my last one. I mean, technically, we only need like the first couple, but we need to be able to see that it is an arithmetic sequence. Okay, so A1, the term at position 1 is negative 25. Sorry, my pen, I think it's my internet connection. My pen's starting to drag a little bit. Okay, and then my difference is, first off, is it positive or negative? It's positive because our numbers are getting larger in value. Right, it's the smaller a negative number is, the higher its value is compared to the others. So, yeah, so it's positive 4. All right, and that's really all we need to write an explicit formula. So A at position 50 is what? Genevieve, negative 25 plus. Yeah, 49 times. Wrong one, right? Clear. So 49 times 4 is 196. So negative 25 plus 196 equals what? You got it right. In my book. All right, so the term at position 50 has a value of 171. Let's look at 89. A89, the term at position 89 is A1, negative 25, plus 49, oh no, 88 times 4.
And 88 times 4 is a big whopping.
You have it?
No.
Oh, I thought you were going to read it off to me.
Well, I told you to write it out.
Oh, that's right. 352. All right, so what is negative 25 plus 352? That's, it is. So that's just 352 minus 25, which is 327.
So I accidentally wrote down 5 on 34.
Yeah.
Negative 5, and got a completely different.
Yes, you absolutely will get a completely different answer because 5 and negative 5 are definitely not the same number. Yes.
And it might be a little small potatoes, but it's a genuine question.
Okay.
You multiply two negatives, it's still negative, right? No, it's positive. Positive. So if you multiply a negative and a positive, it's a negative. Okay.
Always. And if you multiply a negative times a negative times a negative, your answer is negative. So think of it. If you have an odd number of negatives in multiplication or division, easy there, then you're going to have a negative answer. If you have an even number of negatives, you will always have a positive. Okay. All right. We got 10 minutes. Let's see what we can do. Let's look at 38. Okay. So 38 says, if the house numbers on one side of the street form an arithmetic sequence where the first house number is 2, the second house number is 4, and the third house number is 6, how many houses are along that side of the street if the last house number is 38?
So I can figure out like A and then what position it is. And like 19 houses.
So what are we calculating here? Are we calculating a term or are we calculating a position? Yes, we're calculating a position. Because you know the answer? What is it?
19.
Very good. Because why?
Because
Because you divide the term by the difference and it will give you the position. Right? Because essentially, when we look at, if I did it this way, when we look at an arithmetic sequence, really all you're looking at are multiples. But your starting number isn't 1. Which I know that sounds really, that might not make any sense, but let's see here.
that looks cool.
1, 2, 3, 4, 5, 6. So the first number was what? 2? Right? See, 6, 8, 10, 12. Right. So for every position in this case, this one's easy because it does start at 2, and that sort of proves my point here. But yeah, all you have to do really is, what you're saying is that the term at position N equals what do we want to do? The first term plus N minus 1 times D, which is our 2. So we know the term at position N. They gave us that. What is it? That's our difference. And that's our A1. 38. So we know that the term at position N is 38. We know our first position, which is 2, right? What we don't know is N. But what's our difference? 2. Let's see if this works out. I'm not looking at how they're doing it, but I think this should work out okay. So let's simplify. 38 equals 2. Let's distribute. Plus 2n minus 2. Well, these guys cancel each other out, right? Because 2 minus 2 is what? And any number plus 0 is that number. So these just cancel each other out, and we end up with 38 equals 2n. And then you just solve for n. And you find that it equals 19. So that means that at position 19, the house number is 38. So that means there are 19 houses. Okay, so that just proves why you're right. So logically, your brain sees the connection and is able to determine that it's your position term divided by the difference, which is 2. However, this actually works it out according to the formulas that we've learned. Let's do one more. Let's see. So 39 says the first house number in a block is 13 and the 12th house number is 90. Assuming the numbers form an arithmetic sequence, what is the number of the 4th house? So this gives us different information. 39. So A1 is what? 13. And they tell us that A12 okay. So using what we know, we could set up the formula A12. I'm going to write this out so sort of in baby steps, just so you can see where I'm getting the numbers. A12 equals A1 plus N minus 1 times D. All right, so why did I put 12? Oh, A12. I didn't see my A. So what's the term at position 12? 90. What's the term at position 1? 13. And what position are we trying to find? 4. Is that right? Hold on, I'm thinking. No, that's not right. Is that right? No, that's not right. N is 12, right? Because we're doing this for position. What we're doing is we're trying to find the difference. That's what we need. We got to find the difference. Then we can plug the difference in to find the value, the term at position 4. So difference is our unknown, but right now we're plugging in the term for position 12. So N must equal 12 minus 1, and then D is our unknown. So we end up with 90 equals 13 plus 11. Well, we can just leave the parentheses off. It's 11D, right? Yeah. All right, so now what do we need to do to solve D? That heat is like nauseatingly hot. Subtract 13 from both sides, yes. And we end up with 11D equals, what is that, 7? 8 take 77. Oh, this is gonna be nice and even, thank goodness. So what do we do to isolate our variable? Divide by 11 on both sides. And so our difference is 7. So now we know A1 and we know our difference. So we can calculate the term at position 4. So let me put all this down here. So A1 equals what? Wasn't it 13? And D equals 7. So the term at position 4 equals the term at position 1, which is 13 plus N minus 1. So that's 4 minus 1. So 3 times the difference, which is 7. All right, so we have 13 plus 3 times 7 is what? 21. Y'all fell back asleep on me. So the house number for house 4 is what? What do you mean 3? That was the N minus 1. And what is N for position 4? It's 4. So 4 minus 1 is 3. Should I put that in there? Okay. Let me make sure that's right. Yes, 34. All right, so the house number for the 4th house is number 34. All right, good times. All right, y'all are dismissed.